Right. So graphics extension. I haven't figured out why Joy's not working. I've been too busy doing the Shallan thing. Oh, has my mouse stopped again? No. Oh, I've nearly had a worry then. So now I want to do the fill, but I also want to do some other commands first. So what did we do? Reverse box and Joy. So I think we ought to put a character on the screen. I think that's probably the next thing. Now, let's try and find it. There it is. I have been trying to understand what I've done here as a child, as a teenager, and I'm still surprised that I knew all this stuff back then. Really. But I'm gonna try and understand it. I think I've got the bare bones of it. Because there's a lot of chip swapping going on. So what we'll do, let's code it up, put it in, and see if we can get the thing working. So let's add a new file. And let's get this thing started. Right, don't need you at the moment. We'll grab you. But just let me know what you think about doing some streams with the BBC Micro, because I think it'd be interesting trying to learn, because I don't understand the BBC all that well. I knew enough to be dangerous at school because I did my A-level project on it, and I did some assembly. I haven't got the discs, which is a shame, because I think we lost them. Right, so this puts a string on the high-res screen. So C Shift H. Shift H. Have we got a C64 command with Shift H? Oh yeah. It's a left-wing propaganda machine. You've got it on you today, mate. So yeah, so we can't use C Shift H. So it's going to have to be CH Shift A. You might as well just type in CHAR. Right. And the commands are XY text. So X, Y. And oh, the corporation. Yeah, I suppose. And then text. Right, so put that in. Just give me like this. like that. Right, so let's get started. So let's see what we're doing. What am I doing? What am I doing? Why am I initializing that? Well, we'll do it. So we are initializing an X variable by it looks on it. Then we're grabbing the X coordinates. So we'll copy that, put that there, and we are putting in. Oh, we're using XR. XR low, XR high. So that's grabbing X. Oh, right, okay. So might as well copy the rest of it. Grab Y, which is going in RY, I would say. YR, yeah. Now, oh, we're checking for comma again. And this is a new one, AD9E. That's a new one. Let's just make sure I ain't got it already. Oh, not that one. ROM routines. Right. AE9E. Oh, AD9E. AD. I don't see it. Right, let's get the book out. Right, so we're looking for AD9E. Oh, here we go. Function dispatcher vector table. This table contains 2-byte vectors, each of which points to the address of one of the routines. The function is distinguished by a following argument in the parentheses. The expression. Oh, this is where I'm this. Oh, right. Oh, this is probably where I'm meant to be doing those. Right. Maybe this is where I'm meant to be doing RJOY and RPAD. Have to do it on do it on this, but mine's not in here. Right. Next. Where is it? Next. If users. No, it's not. That's perform if. Here we go. Evaluate an expression. Right. This is the beginning point of a very powerful group of subroutines which are used exclusively by BASIC. The main purpose of these routines is to read in the ASCII text of basic expressions, separate the operators and terms of the expression, check them for errors, combine the individual terms by performing the indicated operations, and obtain a single value which BASIC program can use. Is this huge, is it? This can be very complex. This can be a very complex task, as expressions can be of string or numeric type and can contain any type of variable as well as constants. At the end, The flag which shows whether the resulting value is string or numeric at 13 is set. If the value is numeric, the flag at 14 is set. What flag? What flag? Okay. To show if it's an int or a floating point number. So what flag? At the end, the flag which shows whether the resulting value is a string or numeric. OD. Let's have a look. This flag is used internally to indicate whether data has been operated is a string or numeric. The value of 255 is in this location indicates string data, while 0 indicates numeric. Right, so they use a byte. They use an entire byte for that. Wow. The type of numeric data. And so they use an entire byte for that as well. Wow. Right, they only need to use 2 bits. What an inefficient way of right, so okay, so this is the name of it. So we better put that in here. Put it at the bottom because I don't think I've got it. Oi, 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 stop it. Right, AD9E. Yeah, I mean, that's just ridiculous. Taking an entire byte up just for a bit flag. So, okay, so we are evaluating the expression that comes after the comma. Alright, so I presume that's what that is. Then we're doing B6A3. Have we got B6A3 in here? No. So what's B6A3? A3. B6A3. Discard a temporary string. This routine calls the following routine. Okay. Which clears an entry from the temporary descriptor stack. If the descriptor was on the stack, it exits after setting pointers to the string and its length. If it wasn't on the temporary stack and is at the bottom of the string storage, the pointer at the bottom is moved up to deallocate the string. Yes, I completely understood that. How the hell did I do this when I was young? Right. So that is B6 A3. So what does that do? What is that doing? Right, 22 and 23. Right, I'm looking at 22 and 23. Right, 22. No, that's not 22. 22, here we go. Miscellaneous temporary pointers for save area. Okay. So I'm looking at 22. Well, my younger self was looking at 22 and 23 and storing it away. And Y was being stored as well. So I presume Y is the length. So I presume Y is the length. Each 3-byte descriptor, length of the string, start address. Yes. Okay. Okay. So we'll do that. So, my younger self, in his infinite wisdom, did JSR bass underscore F. It's that one, isn't it? FRM num. No, it's that one. And then did this straight after. And then transferred A into Y. And then we loaded now 22 has a name, doesn't it? It's getting there. I'm having to rewrite bits because Sprite Mate was dedicated just to sprites, yeah, and so he had one global class array, for a better word, of sprites, and which were being passed around for all the different components. So with CHAR Mate, I'm having to think of about 3 arrays. So there's a character array, there is the tile array, and then the map array, the screen map array. So I'm having to rewrite a bit because he'd got this sprite array global, and I don't want to have 3 global arrays floating around in the browser. I want to have it structured. I want to have it as a class structures, as I would do it in C#, yeah. And so pass that class around rather than passing multiple parameters around. I'm sure you can do it in JavaScript, but that's what the book's for. But it's coming along. I've actually got it working on the Raspberry Pi as well. The browser in the Raspberry Pi works with it as well. So Index 1. That's the name, is it? The temp area is for Index 1 and Index 2. Okay. So, let's put this in. Oh, I forget where everything is now. It must be in here. Yeah, it is. Right, so we'll put that in there. He's also got another one of 249. So what am I doing in 249? What's 249? That's got to be a spare spite. God, sound like I've had too much drink. I've used that before, haven't I? RO buff. No, there's RI buff. So this is RO buff. So that's F9. Right. So we'll load in index. And we're storing it in that. Then we'll load in index +1, storing it in that +1. So I assume that is where the string is. And then he stores the Y away to RX low. Okay, so I think I think this is the length of string, and this is the, oops, and that's the address. Okay, we'll see. So what am I doing next? Right, so the next thing I'm doing is, have I got the wrong function, the jump vectors? I'm reading where the cursor is. Triple FO. Yeah, I'm reading where the cursor is. So when you use this, if you remember when we was doing the Simon game at the copycat game, well, basically all the cassette 50s, we used this kernel plot routine to put the cursor on the screen. And the way to do that is you set the X and Y and you cleared the carry and then ran the routine, and then that put that cursor in that spot. Here we're setting the character, so what's setting the carry? So that's basically telling that routine we want to know where the cursor is. So he's, my younger self, is then storing that away. So stores Y in com AY and store X in com AX low. I know I've missed that. So we're reading where the cursor is. Then, now I'm not too sure I've got that. I've got these in here. I don't think I have. Oh, I have. Yep, that's the one I want. So then we're going to send the cursor home. So that's kernel. Character out. Character out. There we go. Hey Stacey. I'm looking forward to seeing your char pad, mate, file for Hunchback. I'm really looking forward to seeing how that's getting on, because we need to start thinking about designs. And if you're building a character set for Hunchback, then we ought to start sharing it about to see if we can get some designs put together, and then try and figure out how we're going to do it. But I was really impressed with what I saw on Twitter. You're far better than I am. I'm just rubbish at graphics and sound. Right, so this looks like we are now going to be reading the have you you'll have to. Have you done all the characters that you think, or do you think we? Because I only saw the one screen. Is it just the one screen? Because we need to think about how we're going to what our adversaries are and how we're going to do them. I'm starting to look forward to doing it because it's going to be different. I've never done a platformer before, and I've been watching Shallan's videos to try and find out how to do it. Like I haven't got enough time in the world as it is. All right then. Well, we're gonna because I'm gonna start doing some streams about, because I was watching Shallan streams and I was thinking of doing them again the way he was, but not copying his code because it's his code, but try and replicate it and for a newer audience, because his first streams, you can tell he's really polished now compared to his first streams. Well, yeah. I mean, I've got to set up the GitHub. So we could have some folders underneath there, you know, assets and stuff like that in the GitHub. When I get the GitHub set up, I'll give you a ping, mate. Keep them under 5 hours. The ale, yes. I did watch him when he was getting to the end of the stream. Yes, he was at. How can I put this? His numbers weren't adding up quite readily. Let's put it that way. Yes. I wouldn't say that sort of word, but I'll let you do it. Right. So this is going to be the CHAR looper. Yeah, I mean, yeah, but I thought, I don't want to take away from what he did, but I thought if I redo the streams again, but do them in the way I would do it, I think that would add to the library, because I think he's the master, yeah. I don't come anywhere close to you know, I'm not a master, but I'm pretty adept, and I'm trying to learn all the clever stuff with trying to work out where the sprite is and then work out what the environment around that sprite is. I mean, you know, I don't want to copy his code. That's what I don't want to do. I want to do it for Hunchback, but we'll get there. So that's what I'm going to try and do. Start off at the beginning, because we've already got the multiplexer, which is based on Shallan's multiplexer code. We've got the joystick routines. We've got the sprite if we decide to go with just a normal 8. I'm hoping so. And then we just need to work together, because I don't want to be coding this all by myself. Because, like I say, I'd like to do some BBC stuff. I want to reverse engineer Myriad, which is already thrown a spanner, because I did a reverse engineer of it, and they do some wonderful stuff to throw you off. It's weird. So I'll go through that again when I do the stream. But I have reverse engineered it. I haven't got it to work yet, but we'll go through that. Right, now back to this. Well, that is true. Good coders write great code. Great coders use the best code that they can find. Yeah. As I'm stealing from my younger self. So, it looks like now we're reading the characters from the screen because he started a loop. So we're loading comma white. So we'll load in where the first character is. We compare it with where are you? Oh, didn't I leave it open? No. We compare it with space. And then I am branching forward 7 bytes. 1, 2, 3, 4, 5, 6, 7. So it's there. Okay. So we're doing a. So then I'm doing a kernel. CHAR out. So we're printing the space, increasing the, and then jumping back. CHAR looper. So, what are we doing now then, John? I don't know what 161 is. Let's find out what 161 is. It's 161. So that goes to that, that goes to that. Why are we looking at that? Okay, mate. Why are we looking at that? So branching 11 forward. Is that the end? 128, that's the another one he's checking for as well. Oh, right, okay. It's like 0. Okay. So we branch if carry set. I'm just going to put plus 11 on there because that's what he's doing. 128. And JSR kernel. CHAR out. INY. Jump. CHAR looper. So this is 7. So 1, 2, 3, 4, 5, 6, 7. So it's definitely here. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Right, okay, so it comes here. So anything above 161. Oh, I see. I see what he's doing now. Oh, I keep saying I see what he's doing. I see what I'm doing now. So anything above 32, we are going to print, which is up to here, and then through here, and then here. But then we've got the nothing there. But what he's doing is saying anything bigger than 161, which is this. They're all characters. Anything between 128 and 161, we're just going to print. Because they're print control characters. So, you know, brown, pink, So that is just filtering out all the non-characters. Or I'm filtering out all the non-characters. So, oh, I see what he's doing. I see what he's doing. I've just got it. So we've now got our character. So what he's doing is printing it. Oh. No, wrong one. That one. He's printing it to the screen. And then he's sending it back. So we're printing in the top corner. So we're printing the character, the current character, in the top corner of the screen. So that means we're loading that character. Wow. So he's convert his. I keep saying he is. I am converting the string value into a screen code value without having to use any clever mathematics. Hey, FaZe. If I documented this 35 years ago, yeah. I mean, there's no. Yeah. But it's interesting re-understanding how I did things. So this was my way of converting a pesky ASCII value, for a better word, into a screen code. Is I printed it to the top location of the screen and then just loaded it. Wow. Right, 1415. I don't know if I've got 1415 in there. No, I haven't. So 1415. Let's get the official name for 14 and 15. Line num. Right, so he's loading. Slap sold herself. I'm loading now the screen character value, the screen character value. So if it was an A, it'd be 1, instead of the pesky character would be 65. And then we're going to manipulate it. So we're going to store it in line num, load 0, and store that in line num +1. So now we've got the character value, the screen code of that character, and we've just put it into this line num. And we are, and I think we're multiplying it by 8. Or are we? 1, 2, 3. So that's 1, 2. No, we're multiplying it by 4. Right, looks on it. So we're doing ASL line num, roll line num, so that's 1, 2, 3. So this is times 2. This is times 4. And this is times 8. So we're working. So he's working out the offset of the character, and then we load 15. Add DO, store it back into line num plus 1. And we are storing the current Y index away. So basically what we've done is we've taken, let's say it was character A, taken the character A, stored it on the screen, that's converted into screen code 1. And now we've just times that screen code 1 by 8 to give us 8. And then we've just added DO to the high byte, and that, I've got a sneaky suspicion, is where the character ROM is. I think. So let's see. I think that's where the character ROM is. So char disable IO. So I think this is going to be I think this is disabling the interrupt, isn't it? Right, we're going to have to look at what he's doing, or what I'm doing. Right. No, it's not that. That's the one we want. So, yeah, that's where the character ROM is, isn't it? DO. Right, let's see if it's in this mapping. Chapter note. Right then. So we are. Let's get rid of that. Make this. No, we can see it. Can you see that on the screen there? Just move that over a bit. And move that over a bit. So we're FBing it. So we're FBing it. So that's the 3 bits here, isn't it? So if we're taking the value and FBing it, that means we're masking off. So let's see. I think that's FB. Yes, it is. So we're masking off bit 2, 1, yeah. So we're making that 0. So to select character ROM or IO, 1 equals IO, 0 equals ROM. So right, we're masking out the IO in preference for the ROM, the character ROM. Okay. So what are we doing now then, John? So we're reading the character. Did we set Y to be 0? No, we didn't. So we're physically now loading the character out of the character ROM. So we've just loaded the first byte of the so if it was the A, we've just loaded the first byte of the character A. So he's pushing it onto the I'm pushing it onto the stack. My younger self is pushing it onto the stack. And then we're bringing everything back on. So we're bringing it back on. Let's try and keep it consistent. So we are bringing the I/O back. Okay. Bringing that. Pulling back the byte we've just done, ANDing it with our byte mask. I think that's our byte mask. Yeah. Does it the same? Branch equal, and he's sent it off to char 4, whatever char 4 is. What's char 4 doing? Oh, that's placing. So char 5, where are we going? Are we going char 5 anywhere? Oh yeah. Now, we might be able to do something a bit more clever than this, but it looks like I'm putting it pixel by pixel on the screen. Because we're testing for 8 here, and then we're branching to char 2. Where's char 2? Is that one there? Yes, so this is char 2. Right. Well, but we are missing out this, so we're jumping past this, so we're starting here because we don't want to destroy the X value. Then he's doing I and Y, or I'm doing I and Y, then I'm comparing it with 8 again. So this is the byte now, and that's going back to there. So this, so this is the, right, so this is the, I'm not going to call it that, I'm going to call it line looper. And this here is char pixel looper. Let's make it go to the right place. So basically we're loading in the byte for the letter, for the whatever the letter is, and then we're running through it to find out what bits are set, and we're going to be setting those bits, and this is what works that bit out from what I can see. So now we load X with com y. Line X. Right, so that's increasing. So now we've placed the pixel dots on the screen, and we've run through the entire character. So it's just upped the character length in the string that we're running through, and then we're testing it against rx low, which is our string length. And if it is, it goes to char 6. Char 6 is down there. So what's char 6 doing? Oh, char finished. So if it's equal, then that's it, we're done. We've done with the string, going to return back to basic. So if we're not done, then we're loading XR low. Ah. Bypass the inc statement and load y, so we're re-establishing y again. Load y and then jump to char 1, which is right at the top, I think. Yes, it is. So char 1's up here, which is the character looper. So we've completed putting the character on the bitmap, and now we're looping back round to see if we've come to the end of the string. If we haven't, add 8 to our XY coordinate, So the X would move across 8 pixels, then go back round and read the next character and do the whole process again. So, where are we now? Finished. Oh, that's here. And then we're handing back to basic, but we need to put our cat cursor back where we got it from. So this is where we retrieve, and then we do the jump, not a JSR, to kernel. Oh, no. There we go. Plot. I don't need my command. I don't need to check for out of bounds because the plot routine will do that. The plot routine will check that it's out of bounds and then do an illegal quantity error if it is. So we just add in. We'll just add the number, and then when it goes to plotting the pixel, that's where the out of bounds will generate. So what do we need to do now? So we've got a character 7 and character 4. What's character 4? That's there. Place dot here. So this is character 4. So this is the next bit we need to do now. So this is actually doing the placing now. So we need to store away our registers. Transfer X into A. Oh, now we're doing the add. So ADC XR low. Store it into X low. Right. That's our pixel point, isn't it? X. Yeah. That's our pixel point. So we've just added that and updated the X coordinate. So what are we doing now, John? So we're loading 7. Alright, subtracting Y1. This is because the screen's upside down. We work from the bottom up instead of the top down, so we have to work it the opposite way around. ADC YR. That puts us on the proper line. So that puts us on the proper line, pixel point line. So because we're doing zero, if we didn't mess around with it, it would be 0 to 200. But because we flipped it, so 200 at the bottom and 0's at the top, and we're starting at the top, that means it's 7. That's line 7. So you have to go 7 minus our line number, which is 0 in this position, would be 7, and then we add the Y to it so we know where it is. Right, and then we just do the JSR place. But I'm not too sure if it's called place now. Graphics routines. Oh yeah, it's place. So that is figuring out our memory location. Then we load our branch if +6. We'll work out what the +6 is. Oh no! Oh no! Why are we going there? Oh no! I'll just put what I've put in the code. Jump. Where's CHAR 7? It's bypass dot in it. So we're bypassing that, so it's JSR dot. So this is okay. Right. So we've done the dot. So we're now at bypass that. Right, I've got to find out what we're doing there. Why would we be going there? We're loading X low. Okay. And then re-establishing our registers. Jump to CHAR 5. CHAR 5, CHAR 5. That is on the INX, which is here. Yeah. Right, so what's HCHAR 1? Let me find that. Oh, right, okay. Okay. So this is bit 7 equals 0. Equals normal size chars. One equals double height. Right, so I'm just going to rem that out at the moment because we haven't got it in there yet. But basically what that's doing, so I've got to make sure that, I think that's what we started up here, wasn't it? Ah, yeah, there. Right. So that's the flag for double height characters. So yeah, so that's the next command we're going to do. It's a very short one because it reuses the CHAR routine. Right, that's it. That's it. Right, let's put this in the tokenizer and let's see if we can get any joy out of it. Right, so I need that. We need it in... We need to include it. Tokenizer. Do that. Do that. Right. Right. Let's see if we have any fun. Errors. Are you joking me? That's in the ROMs, isn't it? Oh, did I call it wrong? Which one is it? The first one? Yeah, it's the first one. Oh, Mr. Dollar Sign's out. Just in case you didn't know, a dollar sign denotes a global label. That's what that is. That's what the dollar sign means. Still errors. Come Y1. Haven't we got Y1? Sure we have. Yeah. Screen RAM. Okay. We'll put that in our put in here. Right. Well, none of you spotted that one. None of yous. Definitely, that was... oh dear. Right. Let's see if this works. So we'll put it somewhere near the middle. So X 75, Y 90. All right, let's see what damage we do. Boom. Boom, boom, boom. Boom. Gonna work out. Just make sure I've got this right. Just check the obvious. Yeah, they're all right. Right, okay, so we're going to have to put a breakpoint in here somewhere. Let's get CHAR CBM Prog Studio C64 debugger up and running. Oh, it's not running because I'm on the wrong page. God, that's slow, isn't it? Right. I have no idea why that's slow. Right, let's figure out where our address is that we need. So we want 8E42. E42. Let's put a breakpoint there. Ugh. Come on, keep up. Right. Doesn't even get there. It doesn't even get there. Doesn't even get there. Right. It does not compute. I don't know why. But it doesn't seem to want to... It doesn't even get there. Yeah, that's there. I don't think we've got CHAR in there. And we're matched up. One, two, three, four, five, six, seven. D7. So we're not encroaching on anything else. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. Right then, where's the execute? It's that one, isn't it? That's the one. So we need to put a breakpoint there. So we need to put a breakpoint there. Let's see if this works. Let's see if it's actually doing it. Right. So it should... Oh, and I forgot where our break... Didn't put the breakpoint across, did it? Open. Whatever. Well, it just sent FFFF across as a breakpoint. Okay, let's find the breakpoint for it. Right, where's the breakpoint for it? Here we go. Um, 8329. This is it. This is where we need to go. There we go. So this is going to do the graphic. So this should jump to the graphic, which it has. So we'll do it F11. Oh, am I encroaching on my? Am I encroaching on the space? Oh, come on. F11. Oh, right. Let's load it back in. make sure everything works. F11. Oh. What have I done? Oh, hang on. Oh, hang on. Oh, 1 byte. It went over by 1 byte. It went over by 1 byte. Oh, really? Oh. It's probably why iJoy don't work no more. Well, we'll put that back in now. Tokenizer. Right, let's try again. I think I've hit F6. Yep, I hit F6. F5. How many cycles did you get? Right, so the graphic routine's been moved because we was wiping it out. Right, so we're back on track. Okay. Wonder if that works. Well, we're getting a value, but syntax error. I'll have to have a look in that. Well, it's a lot better than what we had before. Right. List. So 20. Char. 75. 90. Right. Here we go. Okay. That went. Okay, let's make that higher up. That's printing out all the characters. Yeah. That is not stopping. That is not stopping. Right. So what's happening there? If you noticed, it picked J. It picked J, and then plotted J. But then didn't stop, and then so it got K, and then stopped, and then stopped, and so it didn't stop at the 8th line. So, and that's why. Straight away. Yeah, it was because it was running through the entire character set and just plotting it on the screen. Because it didn't stop on the 8th line. So we should hopefully X, say 50. Right, here we go. Get in there. Oh yeah. So that's plotting. So if I, so let's say if we make this a little bit interesting, 15 x equals x equals 50 y equals 90, and then do x comma y, uh, 30 x equals x plus 3 y equals y plus 3, if y is less than 190, then 20. Right. See if that will do it. Run. There we go. So that's CHAR. So basically it allowed you to be able to put characters into the high resolution bitmap screen. And it was pixel, as you can see there, it's pixel perfect. Now I am sure there is a quicker way. Don't overwrite memory. I'm not sure what you mean, Microman. But because we're scanning each lot. Yeah. Well, it'll come back with a syntax error. No, not syntax error. Legal quantity error. So even if we'd get half a character on there or something like that, because it's the place routine that does the checking. So if you say put a pixel at 0.201, 50 or 50,201, immediately the 201 would cause an invalid quantity error. So we don't need to worry about in our routine whether we're going off the screen or not, because the place function does that for us. Right, so the next one, which is going to be a quick one, is the H character function. And that is where we do double-sized characters. But the beauty of it, from what I can see here, is I use the character function to draw the double height characters by reusing all the character code. So let's do that. Let's put another file, but first let's add something here. What is it today? It's the 10th. So we're about to do HCHAR. We'll leave that like that for the moment, just in case we manage to get another one in there. So let's add another file. Hi WauloK. How many? How many have you had coffees? Tell you, I wish I could have that many. Just the one? Oh, right. Yeah, I had a doctor's appointment today. And then, my dad, I should say, I think I'm suffering from what my dad has. But my dad's heart problem manifested itself after mine. Yeah? Does that make sense? I hope that makes sense. Yeah? So he was experiencing the problems after I started experiencing the problems. So he had a heart monitor put in, like me. I've got one just there. Yeah. So every time I have a heart problem, I've got to press that button. Which then monitors my heart and sends it straight to the hospital. And so my dad had one put in last year, October, November time, and his results have come back, and he needs a pacemaker. So he's been booked in for a pacemaker, and so I may end up being like that. I mean, I have the same sort of things. I don't know. He's going to be a cyborg before me. Yeah, it's not fair. I was hooked up to the internet before him, but he's going to beat me on the cyborg front. Yeah, it's. I don't know if you've noticed, every now and then on streams I go quiet for about 15 seconds. That's when I have a what we call an incident, and because this is in my pocket, I just press the button and it records it and sends it off. So yeah. Sometimes if you see me just pause for just a little bit too long, then you know why. Sometimes you can hear the beep that it makes to let me know that it's been marked and it's sending it. Right. Yeah, his is more cute. Arterial fibrillation, AF. Left hand side firing too many times or not enough times. So, and that's what I'm suffering from. I'm also suffering from possible SVT, which is the one that kills you. Right, so enough of that. One, two, three, four. So this is our flag. This is the 6502 in me. I'm a bender. I don't know. I never asked them. No, I think it's too small. It's too small. It's there. just there. Where have I got my finger? Constantly monitoring me. It could. I don't know. It could be because they're low powered, aren't they? Clipped. Oh no. Right. So what we're doing is, before on the draw we had a flag which was that COM XXXL. We set it to 0, but here we're going to set it because we test on the bit 7. So we're going to set bit 7 to tell the CHAR routine that we're doing double height characters. So we need to, so it's +5. So 1, 2, 3, 4, 5. So that's here. So let's put CHAR start CHAR COM CHAR start, so we know where we're going. Right, and then here we jump to that, and then here we are HCHAR. And what are we actually doing here? Oops. Adding second line. Right. So that is what we need to put into the CHAR. Down here that we remmed out. Okay. And then here, so what we've done, we've worked out the memory position of where we're going to plonk it, and then we need to double height. We've got to double height it, right? So you've got to remember now, we've worked out the memory position, the memory location that we're working with. So that Y1 is our memory location for Y. We then logically shift left, that's multiply. Store it in Y. And then we, this is, right, okay, then we're loading 14 because we're double height now, not singles. Set the carry. SBC COM Y, which is our Y value, and then add our originator, Y originator, which is YR. And then we store that back into Y. So that's doing the double height mathematics for where we're putting the character, yeah? So we've worked out where it should be, and now we're going to take it from there and double height it. And so we have to work out the X as well. So they're just transferring it. Right. We'll work out the new place. And we store the dot. Then we increase our Y value. because we're now doing double height pixel placing. So we've just placed the first pixel. Now we have to place the second pixel on the line below. And then we're going to do the next one. So we work out our place and then we draw the dot. And that is it. So you got it. So remember our y value is, so when we're running through the character of 8 bytes, we are now doubling. So what happens is we're going to do that. So every time we move y, we've got to times it by 2, yeah, and then set those 2 lines, and that's what we're doing there. That's at the top bit, and then working out the x is the bottom bit. So let's put this into our tokenizer and see if we can do double height characters now. Right, tokenizer. Hello you. You come visiting, eh? Come visiting. No? Been helping Mummy with a jigsaw, eh? Been helping Mummy with a jigsaw. Alright mate, I've got a stream to do. Yeah, I've got a stream to do. Are you staying there? Okay. Yeah, okay. Yeah. Are you going there? You going? Right. Let's see if we can get double height characters going now. Well, we know the single height's working, so we know that system's working okay. It's just a case of our double maths. Um, 70, 90. Right, let's see. Oh, boom. Have I got the maths wrong? Hang on. Have I? Yeah, not so great. Com1 times it by 2 puts it in com-y. Loads 14, subtracts y. Adds YR, stores it in Y. X loads X1 low. Oh, hang on. I forgot something. store it in X low. Right, that's what I forgot. Loads XR high, adds 0, stores it in X high. Place dot, increase Y. Increase Y. Oh, missed another one as well. Not paying attention. Not paying attention there. John broke it. Yeah, as I always do. But I wasn't paying attention. How can I miss 3 lines? I've done that before. Just not paying attention. There we go. There we go. It would help to have all the instructions in place. Oh. It would help to have all the instructions in place. So there you go. That's how I put, as a youngster, how I put the sprites on the screen, on the not sprites, on the characters on the screen. But there is a problem, yeah. Let me try and explain. Let me just create a sprite. No, I won't do that. Let me log on to Sprite Mate, and so I can try and explain. Right, so pretend this is the bitmap in the background, yeah, and the sprite is 3 characters wide, yeah. But let's just assume that this is the terminator between 1 character here and 1 character here. So, you know, what I do with, let's say, the character A is, if my start point is there, right? Hang on, 1, 2, 3, 4, there, right? Now, the first line of the A is 4 pixels across, yeah? So, let's... Paste codes. Right? Oh, I can't blow into it. Can't get... LV. Where's LV? Oh, I know. Oh, that address. Have I got that address down? Yes, there it is. Right, let's do it on here. So, character. Right. So, the A top line is nothing, dot, nothing. So what I do, or I should say what my younger self did, was we work out that point there, and then we say, have I got a pixel there? No. Have I got a pixel there? No. Have I got a pixel there? No. Have I got a pixel there? Yes. Have a pixel there? Yes. No. And then I do the same thing again. Pixel there? No. Pixel there? Yes. And that is slow because you're having to run through all 8 pixels, trying to work out if the pixel point at that point should be set or not. And I was thinking about this over the weekend. I'm sure there's a better way of working it out, yeah? So I'm sure there's a better way that we can do it. So if we had a break here and another character there, yeah, that instead of saying, have I got a pixel there? No, no, yes, yes, no, 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 no. That we would work out how many pixels we are into the character, yeah, by using the maths, and then when we get the character from the ROM, we then do some shuffling. So we would shuffle it right. So we'd end up doing that, yeah, and then set. So this would be blank, yeah, because it would be nothing. But then set those 8 characters to be that. Move on to the next 8 characters, and then we've got our original character, and then we would shift it this way to get this side of it, yeah, and then OR it onto the bitmap. And I think that that way would be quicker, because then we are basically working out our byte mask to OR it onto the bitmap screen in the background. And that would take less time, because what we would do is we would work out our memory location for the pixel, which would give us the byte location, and then from that we would work out how many shifts we have to do it in either direction to give us the approximate mask to put onto the screen. And I think that would be quicker. How we're going to do it, that's another thing, but I think it would be quicker that rather than plotting each pixel point, because then we're having to plot 64 pixels for every character, when really we don't need to. We should be able to either just do 8 ORs, stores, or if it crosses the boundary, you know, we just have to work out where it is. So, but I'm going to leave it at the moment there, because I need to think about it a little bit more to see, to make sure that every possible, because you've got to remember that as well as crossing from this side, we'll also be crossing from up, so we'd have to do shift, you know, the shift up and shift down, yeah, to make sure that we've got the right correct bit mask. Alright mate, take care, I'll see you next time. And let me know about the CHAR pad thing. I'll get the GitHub set up and I'll invite you to it so we can start storing stuff on there. So that, I think, would be a quicker way of working out where to put the character, is work out where the byte is that we need to alter, and then work out from the character mask what we need to do to it to put it in that storage space. And yeah, that would be some thinking, because we have to work out the differential between where we are at and where the character would be if we stored it straight onto the screen. Yes, but that's a thing for another day. I'm not going to do the fill because I've got to work out the logic for that, because I really do want to make that work. But what we can do is we can have a bit of fun by trying to get the sprites working. because we have got, I mean, we've got mob as well. I don't know what mob does, and I've lost my manual. Yeah, I mean, the fill does work. It's not intelligent enough to shuffle left or right to see if there's anything more. I just go up and down in a straight line until I hit a bounding, and that's it. That's what the fill does that I wrote as a kid. But I'm not too sure what mob does. Because my instruction book, I've lost some pages. I've lost some pages at the back. So hang on. So over the 30 odd years. Mod. Mute. What's mute? Oh, no mute. Oh, I can't remember. My memory's a sieve. Right. So this was my extended basic, my machine code monitor, my assembler, and my graphics extension user guides. But it doesn't go all the way to the. So because pages, after 30 years, the back pages have come off. And where's mob? Let's see if mob's here. Ah, mob. The mob command is used to set up the information about the sprite. The parameters are, yeah, mob. What would a mob become? What's mob mean? You know, in Minecraft when we say hostile mob. What does mob mean? Oh, movable object. Okay, there you go. Thank you very much. No, I was just asking. So I've got a command that says mob, yeah, and I don't know what it is. So it says here, the command is used to set up the information about a sprite. The parameters are the sprite number 0 to 7, the pointer to where the data is stored for the particular sprite 0 to 25. So that's the sprite pointer. Whether the sprite pointer is off or on, is the sprite expanded horizontally? Is the sprite expanded vertically, and has the background got the priority over the sprite, and is the sprite in multicolour mode? So there's a lot of commands there. So we got sprite number, pointer, on, X, Y, black, and right, and it says here. Example, look at the sprite command. Right? The sprite command is missing out of the book. Because I think I've lost a few pages. And I can't find the user guide. It's got to be somewhere on my disk somewhere, and I can't find it. And I don't know how the Sprite. I don't know how to work it. I don't know. You have to put one, but it's irrelevant. We can work it out. So, yeah. So I've got mob, and then there's mob color, and the mob color command is to use to set both the multicolor elements of the sprite when the sprite is in multicolor mode. So we can do those commands. What time is it? 10:30. But yeah, I've lost a couple of pages of my manual, so it's great. You know, if I just love the way I've put. If you want to example, it says example. Look at the Sprite Command example. Oh, rubbish. But I must have this because it's in what was it called? EasyScript word processor. Because I wrote this when I was working. I think I was working because I bought a 64 for myself because my folks still had the 64 that we used as a kid. So I bought one myself, and I used that 64 to run my finances, which we are going to do a stream about how to make a checkbook software. So we're going to be talking about databasing and all that. How about testing it out with the original? How about testing it out with the original program? Yeah, that's a good thing. Good shout there, mate. We'd have to make a sprite. We'd have to make a sprite. What's a check? It's 2020, Grandad. Look, I'm not going to argue with you. I wanted to do a database in to show that the 64 was a pretty good database. You could create databases, and you could do quite a lot with the databasing as well. So it was called Bank Prog, I think I called it, and it ran my folks' finances because I wrote it originally for my mum, so she didn't have to write it out on paper and pen. Because once we'd left home, you see, they had a computer they could play with all the time instead of the three kids gobbling up all the time. So I wrote them a program. So I'm going to be doing that, but it's all written in well, it's not all. It's 90% basic, 10% machine code. But that's going to be a different stream series on how we can write a financial tracking program to run your current account, for example, based on what I wrote to look after my finances. Anyway, so let's try and test it out, but I need data. I need data for I can use the Neptune lander data, can't I? Yeah, let's load the Neptune lander data in. Save this. Open project. Right, where's my sprite? Here we go. File. Export. to listing, generate 3 basic data starting at 1000, only generate included sprites, but I only want the one. Give me the one, just one. 1-to-1. There we go. Cut. Undo, 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 undo. There we go. That's back to normal. So, put that in there so I don't. But I asked for it in I asked for it in basic. I didn't ask for it in assembly. I asked it for in basic. Export to listing, basic data. Okay. Can't put it in there because that's already got it. Let's create a new basic program, add new file. Yeah. I'm just after the line numbers as well, mate. Basic data, line 1-to-1. That's better. So we'll put that in there. Right. Let's load the code in. That one. Is it that one? Yes, 19. Star. Right then, graphics extension. So let's copy and paste this in. Oh, you're joking. Oh, well, that didn't work, did it? Edit. Replace data with data. That's it. Right, so 10 for I equals 0 to 63. Read A poke. 12288 plus I, comma A. Next. So that reads the sprite data in. So we're doing on sprite, we're doing it on 192. So we need to set up the mob. So let's go back into here and let's now into here. So this is my original code. Let's see what we're doing. Right, okay. So mob number at the pointer, whether it's on. Number pointer so that stores it there, and whether it's on. So I'm just wondering if that's a 1. Okay, so I wonder if it's just 1 or 0. So let's try it out. So 20 mob 0 192, because that's where it is. On expanded X, expanded Y, 0 0. Right. Right, 30. Now I don't know what sprite is. Where's sprite? Here we go. So the syntax error is sprite number, X, Y, and color. Okay. So sprite 0, comma 100, comma 100, comma 2. That's red, I think. Alright, see what happens. Out of memory. Oh. Oh, there we go. Hey. There we go. So we should be able to modify this, right? So mob 0 192 on. We'll leave that on. We'll turn that off. We'll turn that off, and we'll turn that off. Fat. Makes it small. Put. So now, okay, so we'll make it big, back to big, and then this one should put it behind the text. There we go. And this one will make it multicolour. So that brings it out in front. So we can change the multicolour text, multicolours by doing mob color 1 and 2. So mob col. So we said it was red, so we'll do yellow and that. There we go. Cool. Right, so that's that is how it. That's how mob, the mob sprite and mob color worked. So it basically allowed you to create a game and control the sprites without having to do all those pokes. Yeah. So you could control the sprite doing all the so you had the mob that sets up your sprite, and then the sprite is the thing that moves it around and changes the color and stuff like that. So let's see. Well, let's. The easy one to do is probably the sprite. That's the easy one to do. Is to get that Sprite command up and running. Right. Let's put this back here so I can see what I'm doing. And we will load the project back in. So we're going to have a crack at Sprite. Right. New file. Let's grab, well, we don't need that. We'll grab that. In fact, we'll grab all that. But we don't need you. Paste that there. Now, have we got S Shift P? Yes, we have. Okay, so it's going to have to be F S P Shift R. Yeah. Function to place right. Sprite SP Shift R. Is there? which is just describes Minecraft straight away. Right, so the first parameter we'll put it in is the sprite number. Next one is X and Y. Right, it's banging on the wall. And the last one is the sprite color. Right. So the way we would use it is this sprite, as you've just seen, sprite number, comma, X, comma, Y, comma, color. Right, so it's simply grabbing numbers. So we've got them already. So we just need a single number, which is this. Just grab the single number. So this is the get sprite number. And first we check to make sure we're not putting a number in we don't need. Now I've done +3 again. So B248, B248, that rings a bell, that one does. B248, I think that's syntax error. B. Here we go, illegal quantity. So basically, no. So we get the byte, the sprite number byte, we compare it with 8. If it's less than 8, then it's a valid sprite number. If it's more than 8, we generate an illegal quantity error. And so we then store that in com axlow. So the next thing is to get the comma. Oh, might as well grab a bit of this, grab a bit of that. So check for a comma, then we get a 2 byte, get a 2 byte, so this is X for the sprite, and here I have got let's do that, because now what I'm doing is I'm testing. So I test the high byte with 1, branch if less than +8, branch if equal +2. I'll work all these out in a minute, and then branch if carry set +12. So this is going to up here. Now on my code I've got a jump down, so I've got jump down, so I'm saving 3 bytes here. So so do I store it? Hang on. No. So 2 is here. So we're testing xlow cmp #100. That can't be right. 256 320. That's not right. What's the maximum? What's the maximum X we can have on a sprite? Oh, that's SID chip. SID chip. There we go. What's the maximum X? Does anybody know? Oh, 80 plus 40 times 8. Okay. $144. So this needs to be 144. Yeah, we're just checking that we don't go past it. So 144. So branch if greater than, and we'll go to illegal error. So if it's greater than, but you can have 2 to the 9. Yes, I know. And then we store it, store A in X low, store Y in com X high. So this is testing low, and plus 8 is 1, 2, 3, 4, 5, 6, 7, 8. So that's that. In fact, we'll make that temporary. Make them temporary. So basically what that's done now is check the X dimension, yeah? So we get the 2 bytes, then we check to see, are we 1? If we are not 1 or less than 1, then we come here and store it straight away, yeah? But if we are equal to 1, then we test the low byte. And if the low byte is 144 or higher, then we set an illegal quantity. If it's not, then we store it. And that's how we can check to make sure the X is within the bounds of the screen. Next, we are getting, the comma again. And then we're getting to get another single byte. And this time we don't check. So we're storing X straight into com Y1. Right, so that's got our dimensions, and what we right, okay. Right, so we load COMX and divide by 2. No, times by 2. That's that way. Times by 2. Transfer it into Y. Then we load X low and then store it in increase Y A com Y and store it in now. We can do better than this. We can do better than this. Right, where are we? Have we? Do we have the sprites? Do we have the constants in? Fixture locations. There we go. So we'll do that. So that one can go there. But we won't bother with the increasing. And we'll do that. There we go. And then LDA com x high. I don't need to do that, do I? I can do branch if not equal. Branch if equal to 0. So if it's equal to 0, I don't need to do anything. So LDA #7. Set the carry. Subtract our sprite number. Transfer it into X. LDA our most significant bit. Or it with byte mask. Comma X. Store it back into there. Easy. Right, what's Sprite 2? Ah. Okay. Right, so we've got Sprite 2. What's Sprite 2 doing? Loads the mask, XORs it, 64. Oh, I see. I see. How do I turn that? There's a bug in there. How do I turn it off? How do I turn that off? Yeah. I don't turn that off. Right, so let's think this through. Okay. Yeah, let's do that. So we're transferring to X. So the first thing we need to do is load our byte mask. XOR it with 2, 3, 4, 1, 2, 3, 4 to flip it. Then AND it with Vic to MSGX. And then store it. That needs to be worked out up here. So we turn it off, check to see if the high byte's on. If the high byte's on, X will still be valid. Load the or it and then put it back. If it's not valid, we bypass it. Right, okay, so we've checked the X and Y, so now we've set the X and we set the Y, and now we need to do the high byte. So the first thing we do is work out what the sprite pixel mask is, XOR it, so it turns it off. So let's say we do sprite 4, 0 is the first. That would load a 0, 0, 0, 1, 0, 0, 0. XOR it, that becomes 1, 1, 1, 1, 0, 1, 1, 1. And it with what we've got already in there, and then store it back. So that turns that bit off. And then if com high is set to 1, so if it's 0, we bypass it and come to here. But if it's any other value than 0, which the only other value it'll be is 1, then we set the bit to make it go into the X region. Right, now, and that was a bug because that was not in this code. Well, well, well. See, I was fallible. Right, so now we need to check for another single byte, I think, which is this. Oh no. Well, we need to check for the comma. But it's this one. Check for a byte. This is Y. And here is the colour. So I check for 16. If it's less than that, then we jump. Right, so we jump to a legal, we'll jump to their legal quantity. So here is set color. And right, so transfer X into A. We load the sprite number and we store it in the blue cable is connected to the red cable. Right, okay. So that should be it. Transfer X into A, load X with the sprite number and update the sprite color and then return. Right, that should be it. Sprite. Have I closed it? I must have done tokenize it. Right. Just make sure. Don't need that. Don't need that. Or that. Or that. Right, Sprite. So we've got the right thing. Right, let's try it out. Do we get an error? Yes, we do. Oh, Xlow. Well, looks like we're on good. Okay. Right, so 10 for I equals 0 to 62. Read A poke 12288, I think it was, wasn't it? Yeah, 12288 plus I, comma A, next. So that's going to read our sprite in, so we'll paste that in now. Right, 20 sprite. Ugh. Oh, we're not going to be able to switch it on. We'll have to do that manually. Sprite 0, 1. Oh, we're not even setting it. Maybe we have to do the mob. But we'll put it on. Oh, 20, 30, because we'll put mob. Sprite 0, 70, 90, 2. Right, save. Right, got to poke all that everything in. That's 40 poke. Got to switch it on. Switch it on. Switch it on. Come on, John. You should know how to do this. Horizontal, vertical. No significant bit. Fine scroll. How many times have I done this? I'm only looking for the current raster, the decimal value of it. Light pen, vertical, enable. Here we go. Poke 53269, 1. Oops. 53269, 1. So that enables it. Right. Let's see. There we go. Poke 1024 2040, isn't it? 45 poke 2040. 192. Wrong. There we go. Right. So we've got the sprite on the screen, so we could really, I should have put those two in front. So 11, 12. So they're out the way. Get rid of 40, 45, and then just do 24i equals 72 140. Put I there. Uh, 44 DE equals 0 to 100,000. Next DE. In fact, 500. Puts a delay in it. 50. Yes, it does. Next I. Right. That should move that sprite. There we go. Across the screen. Let's make it a bit quicker. There we go. So that's the Sprite command now working. Whoa, what happened there? Ooh. Ooh. What happened there? No. Cancel. Leave that there. Let's do that again. Right. That enables the sprite. That's all I need, isn't it? Oh. Right, so 24i equals 70 to 140. I. Yeah, I'm just, yeah. Right, let's see what happens. It disappeared off the screen. Yeah, it jumped off the screen and then came back and then boom. So I'm not going to load the program here. I'm just going to check 6, 4, 7, 3, 8. I need to find the where's the start point for it? Hang on. Where's the start point for it? That's HCHAR. That's not up to date. Right, Sprite, where are you? Oh. According to this, I didn't put it in. Oh. That's rubbish, that's not right. Yeah, that's it, should be in there. Place dot HCHAR, where's Sprite? Oh. 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 That would explain a few things. Let's try that again. That would explain. All right then. See if it does it again. Yeah, so it's still doing it. Right. So it wasn't the fact that it could have overrun into the graphics area. There is actually a problem with it. Right. Let's find the address of it. Sprite. Here we go. 901B. Yeah, that's what I'm going to find out. It's got to be somewhere in the Vic chip. 6, 4, 7, 3, 8. Yeah. 901B. There we go. Right, so got to replicate the same thing for I equals. Why is everything in a different place? Where on earth's equal? I can't find the equal sign. Can't find the equal sign. I can't find the equal sign. Oh, where on earth is it? So annoying. Ah, there it is. What on earth is it doing over there? Right. Now I know where it is. 70 to 140. Gonna say 0, comma, I, comma, 90, comma, 1. We don't need to worry about a delay because we're going to breakpoint it. I have a lot of patience. This is a good day. This is a good day. Right, so we should be breakpointing when we run it. So let's run it. There we go. So so this should be getting the sprite number. So we're not worried about that. So we'll put a breakpoint there and F11 it. That's it. So X is 0. That's correct. Now we need to, we'll put a breakpoint there, F11 it. So Y is 1. No, it isn't, because we are less than that. And A should be, yeah, that's the equivalent of, no, it isn't, is it? Oh, yes it is. Yes it is. Right, so F10 it. So branch, it's going to be carry click. So it stores A and Y in 9. Then we do the color Y. So we'll put a breakpoint. So this is Y, 5A. Yeah, that's right. So that's the first one, but I've not activated the sprite, have I? Okay, let's see if I can break this thing. Oh, it's not going to break out. Break, 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 break. Come on, break. It's not going to break out. I know. D. Here we go. Right, so enable is 15, 10, 11, 12, 13, 14, 15, 0, 1. Right, so that should be set, and we'll set of course, hacking the memory. So is it F7? F8. 0, 1, 2, 3, 4, 5, 6, 7, 8. Set that to... Do we see a sprite on the screen? No. Well, that was set, so it's on. Right. F10, F11. Right, we're enabled. We're on. Okay, but where are we? Which is the screen that shows me where everything is? There we go. There we go. Right, we're on. We're on the board. This is where the sprite is. So, Y still 0. A is going up. Right, it's going up again. Right, so I've got to figure out, it's got to be something to do with this here. Let's see what happens. So we're at 2C, that's Y, and we're still moving up. So it's 6.3 now. 6.3, what would that be? Nice. Right. So I'm just gonna... Right. So we load A with CO, which is 0. That's right. Times by 2, transfer it into Y. Load 63. Store that there. That's okay. B5. Store there. Load 7. Minus 0 is 7. Transfer it into X. Load 90F. Load 908F. What? That's wrong. This is wrong. This is not working. I'm sure it works. It's got to work. Oh dear. Why ain't my raid alert worked? Oh, it has. Hello. Oh dear. Revenge raid. Revenge raid. Cheers, mate. I didn't realise it was that late. Hello, everyone. Welcome to our stream. It's normally me raiding the other way around. How are you guys doing? This is my first raid. Well done, mate. You've actually my first raid ever. You enjoy what you was doing? What was you doing this time? Yeah, it's first raid. First raid ever. Right, we are coding 64. Oh, thank you. Yes, he did. Yes, he did. No one else can claim that now. Oh, thank you for following, guys. Right, what we're doing here, and I was getting ready to close up. Football camp. Oh, we're doing we're creating a graphics extension for the Commodore 64, so to allow us to draw lines and stuff like that. What we're trying to do now is trying to make the Sprite Command work, and we've got a bug, and we're trying to figure it out. So yeah, just got a little bit of an issue, poking into the wrong place. Don't know where, don't know why. But crikey, I've never had so many people on a stream before. 48. Can it give the 64 more colours than brown and grey? That's cheeky. So yeah, so at the moment we've got a bit of an issue with the Sprite Command. It's throwing a bit of a fit. So let's just run it just to show you. 48 people on my stream. Wow. So it's all done in machine code 6502, and we are creating custom basic commands to allow us to draw lines and sprites and stuff on the screen. So this is the sort of thing that we're doing. So let's say we've got a circle here. So there's some custom commands in there. So circle is a custom command and graphic is a custom command. But I think I've got other ones. Hang on. A better one. Circle 2. That's the one. There we go. So it allows you to draw lines and stuff like that, which you can't do on the C64. There's no graphics commands whatsoever. Anyway, let's get back to the bug in hand. So we have a sprite on the screen, but it throws a fit. Or is it Sprite 2? There we go. And watch, it'll disappear off the screen. There we go. And then it starts messing around. There we go. Bang. And I think we're poking, look, because it's changed colour now, and I think what we're doing was poking into other VIC registers, but just got to find what the VIC register is that we're damaging. And that's the problem. We are now in debug mode. Yeah, basic, but these are commands that we've created, so we are poking the VIC in all the wrong places. Yes, and I don't know why. I'm just wondering if we're getting a bit of maybe that, but I think it's this here. I think it's this here. Because it can't be that. So I think it's this going a bit awry. Oh well, back into debug mode. Well, yeah. I'm going to have to get this to auto reset when it goes in, really. There we go. Right, let's make sure we set up the sprite pointer. Oh, what was that number again? 53269. Turn it on. Turn it on. Come on. Turn it on. Right. Equals. Oh, and it's too slow. Oh dear. You can still learn now. Still learn now, definitely. I never gave up. Right, so we need to put a breakpoint in 901B. That's where it was, wasn't it? So this is it. So what we need to do, we was breaking it there, wasn't we? At that point there. That's what we're looking at. And O2BO is the data we want to check out. There we go. Alright, take care. Right, here we go. Let's run this and let's track it through the system. So, our sprite is there, I think. That's the one. But we haven't set it, so we're just about to set it. So it should move. There we go. So it's there now. So it was moving across. And we're looking at these numbers here. So it's moving across, but I don't know why it goes back. So let's see. Transfer it, loads that, which is 58. Yeah. Stores it there, loads B5. Yeah. So that's 0, transfers it, loads the bit mask. That's right. And it with DO, store it with DO. Okay. There, right, we moved. Why did we move? Why did we move? Now it's up there. B5, B5, what's in B5? That's 5A, so that's right. So we're off the screen. And now we're back on again. Yeah, you're not the only one who could do that. You use STA 0, so if Y is 11. But Y would never get to 11. That's what's concerning me. Right. Let's see what it's gonna be storing. Where's Y? Oh! Hello. No, Y's 0, so we're fine. Seven. No, it's still moving. It's still moving. Where are we up to now? We was at 140, so 140. So that's at 60. 5A, so that's still right. Ooh, wrong one. $65, yeah, that's still fine. Ah! We shot off the screen. What are we at here? 169. But we haven't gone through the... Why has it gone across there? This value here, watch it change. So as the raster comes down, it's changing. So it's at 68, and when we get to the bottom, 69, and then suddenly it's 169. Why? Why? something set DO10, but it wasn't us. Yeah. Right. This is the code that sets our high bit, and it's not run because it's not white. So something else has set the high bit of that sprite. Yeah, I bet you if I go to, hang on, let's find it. DO, where's the, here we go, there's the memory. If we go to DO10, I bet it's set. Here we go. Right, so 1.8. Yeah, look, it's set. F8, 9, so that's DO 8, 9A, yeah? It's got a 1 in it. It's got a 1 in it. So something's put a... Oh, what could have put a 1 in it? Because we haven't... Yeah, someone put a 1 in it. Now, oh, what on earth going on? But it wasn't us, because we haven't run through this code. Let's see if it turns it off. 0. Transfer A into X. Load 01. XOR it. Store it. Right, it's back. Okay, what's up? No, I've just run through that. It was 0. That's my new alert, because I don't pay attention to chat. That's what I don't understand, because I am... Where's it gone? So now it's drawing the screen. And I bet the screen's going to go blank. Y 0, so that's fine. XOR, so it turns it off, but we are modifying. We've got to be modifying. Oh, hang on a second. Oh, 1. Load X. Oh, there we go. There we go. Now it's here. It's down here. X is at 6B. DO27 plus X. This is the area. This is where it's wrong here. Right, I know where we are. This is not the sprite number. The sprite number is this. Oh, all that. Right. Yeah, we've just we finished Grid Runner. Well, our version of Grid Runner, but we made it for all of them. So we made it for the PET, the VIC-20, the C64, Commodore 128 and the C16 using one set of code to do it. It's my my first. I've done some games for the competition, the Cassette 50 competition. Hang on, let's find it for you. So this is the Cassette 50 competition that's currently running. So you should see a couple of mine. I've done 4, I think. Right, there you go. Pexkipede, that's one. Scryamble, that's another one. Line 'em Up, which is like Connect 4. And Copycat, which is over here. So these are games that I've done 4 games for this competition, but quite a lot of my viewership, like WauloK, he's made one. Oh, he's made a couple. He made an adventure game, wherever it's gone. Where's it gone, mate? There we go. There's, oh, this is Little Adventure. That's the adventure one, isn't it? Then you did the horse racing one. Yes, I've never coded a game till now. I've always been an application developer. So these are my first ever games. So the Grid Runner one, which is basically disassembling Jeff Minter's game and recoding it with modern techniques. Thank you. Thank you. Right, let's see if we can get this thing working. But we're going to be doing, we're going to soon start work on Hunchback. So we're creating Hunchback, the classic Hunchback game for the Commodore 64, but we're going to modernize it, so it's going to be a big platformer. So we'll have screens dedicated as a homage to the original Hunchback, and then we're going to have a big massive map for Hunchback, and that's our next serious gaming project, and the community is going to get involved in there. So we've got Stacey Bates. He's starting to work on some of the graphics and the maps and stuff like that, and hopefully we'll get other people to do sound effects and do that. Yes, exactly. So yeah, I love the original. I played it too many times when I was a wee whippersnapper. Right, so this should now be fixed. Come on. There we go. There we go. Right, so the Sprite Command's now working. There we go. Didn't crash it this time. Didn't crash it this time. Right. So, let's add the comment. So we've done the Sprite. Right. Well, thank you very much for joining me, you guys. And the guys who raided me. I do this Monday and Wednesdays. Code, different things. Cheers, matey. Thanks for the bits. Let's get this in Git. Right. Yes, I'm a co-developer on it now. I'm the person responsible putting Git in CPS. We've got some other things coming in. We've put Mega 65 in, Basic 10, and we're hoping to have an assembler for it soon. We're also doing Kick integration into it as well, so we can integrate the Kick assembler into it. So yes, I'm helping the original coder out with new features and stuff like that. So yes, and that's why my name's on the start page. There we go. That's me. But yeah, it was one of the major features in the last update is Git integration. Right then, guys. Well, thanks a lot for joining me. It's been a pleasure. I can't raid Cyvoid now because he's here and there's no one else. So thanks everybody for joining me. I hope you have fun, and I'll be uploading this to GitHub shortly. Alright guys, take care. Thank you very much for joining me. See you later. Yeah. Take care. Bye. I'd like to thank all the patrons that are contributing to my channel. Without you guys, I wouldn't be able to do what I'm doing right now. Thank you very much.